Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.13. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.13. Use mesh equations to find voltage V0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of voltage across this 6 kilo ohm resistance labeled as V0. And it is also mentioned in this scenario we have to use mesh analysis to solve this problem. So without wasting time, let's proceed towards the solution. In order to perform mesh analysis on a network, we have to follow some steps. First step includes finding out the number of maximum meshes that can be formed in a network, and that number of meshes can be obtained using this equation. In this equation, B is the number of branches, N is the number of nodes, so we can use this equation to find maximum number of meshes that can be formed inside this network. Number of branches in this network is 6 and number of nodes is 5. Place these values inside this equation. So the maximum number of meshes that can be formed in this network is 2. These two meshes can be formed using these paths inside the network. This will be first mesh and second mesh will be formed using this path. In next step, we have to assume currents along with their directions inside these two closed loops. We are assuming current I1 is flowing through this closed loop and current I2 is flowing through this closed loop, and both currents are flowing in clockwise directions. According to the direction of currents, polarity notation across resistive elements is marked. Now we will apply Kirchoff's voltage law inside these closed loops to find out two mesh currents equations. Kirchoff's voltage law equation for this closed loop will be plus 3 volt current is entering from positive terminal, so voltage across this voltage source will be taken with positive sign. Next, current entering terminal is positive, so voltage across this 2 kilo ohm resistance that is labeled as V2 kilo ohm will be taken with positive sign. Next, voltage across this 4 kilo ohm resistance will also be taken with positive sign because current is entering from positive terminal. And at the end, voltage across this 2 kilo ohm resistance will also be taken with positive sign because current is entering from positive terminal. Now we have to replace these voltage with their respective equations. Voltage across 2 kilo ohm resistance is the product of current I1 and 2 kilo ohm. Similarly, voltage across 4 kilo ohm resistance is the product of current through it, that is I1, and the value of resistance 4 kilo ohm. Voltage across this 2 kilo ohm resistance will be equal to the product of current through it and the value of resistance. Current through this 2 kilo ohm resistance is the difference of current I1 and I2 because these two currents are flowing through this 2 kilo ohm resistance in opposite direction. Here we have taken the polarity notation of voltage across 2 kilo ohm resistance according to the direction of current I1, which is indicating that current I1 is larger than I2. That's why we have subtracted I2 from I1. Now open these brackets and take the product of 2 kilo ohm with variables inside the brackets. The equation will become 3 volt plus 2k I1 plus 4k I1 plus 2k I1 minus 2k I2. We will add these values together because these have same variables. 2k I1 plus 4k I1 and plus 2k I1 will become 8k I1. Place this constant on the other hand side of equal. So the equation will become 8k I1 minus 2k I2 equal to minus 3 volt. This equation cannot be further solved, so we will leave this equation for now and label this equation as equation A. This is the first mesh equation of this network. Now we will apply Kirchoff's voltage law inside this second mesh. Start writing Kirchoff's voltage law equation from here. Current entering terminal is positive, so voltage across this 6 kilo ohm resistance will be taken with positive sign. Next, current entering terminal is negative, so 3 volt will be taken with negative sign. Next, current entering terminal is positive, so voltage across this 2 kilo ohm resistance will be taken with positive sign. And at the end, current entering terminal is negative, so 6 volt will be taken with negative sign. Now add minus 6 volt and minus 3 volt together, it will become minus 9 volt, and replace these two voltage with their respective equations. Voltage across 6 kilo ohm resistance will be equal to the product of current through it, that is I2, and the value of resistance 6 kilo ohm. Similarly, voltage across this 2 kilo ohm resistance will be equal to the current through it and the value of resistance. Current through this 2 kilo ohm resistance will be equal to the difference of these two currents, because both currents are passing through this 2 kilo ohm resistance and both are opposite in direction. Here, because we are taking the polarity notation of voltage across 2 kilo ohm resistance according to the direction of current I2, which is indicating that current I2 will be large than current I1. That's why we have subtracted current I1 from I2. Now open these brackets, take the product of 2 kilo ohm with variables inside the bracket. The equation will become 6k I2 minus 9 volt plus 2k I2 minus 2k I1. Add values including same variables together. Place this constant value on the other hand side of equal and arrange the equation. The equation will become minus 2k I1 plus 8k I2 equal to 9 volt. And label this equation as equation B. It is the second mesh equation of this network. Now using these two equations, we will try to find out the value of current I2. And we are interested to calculate the value of current I2 because using this current we can calculate voltage across this 6 kilo ohm resistance that are labeled as V0, and in this scenario it is asked to calculate the value of V0. So in order to find the value of current I2, we will multiply this equation B with 4 and add that resulting equation with equation A. So we will take equation A as it is and take the product of 4 with this equation B. It will become minus 8k I1 plus 32k I2, and product of 4 and 9 will become 36. Now add these equations together. Minus 8k I1 and plus 8k I1 will cancel out with each other. Subtract 2k I2 from 32k I2, it will become 30k I2. Similarly, minus 3 volt plus 36 volt will become plus 33 volt. Now in order to calculate the value of current I2, divide on both sides with 30k. So the value of current I2 will become 1.1 milliampere. After calculating the value of current I2, we can use Ohm's law to calculate voltage across this 6 kilo ohm resistance. That will be equal to the product of current I2 and the value of resistance. Place value of current I2 inside this equation and take the product of 1.1 milliampere and 6 kilo ohm. It will become 6.6 volt. Milli will cancel out with kilo and product of 1.1 and 6 will become 6.6 volt. So the value of voltage V0 inside this network is 6.6 volt. So this was chapter 3 learning assessment E3.13. Thank you. See you again in next video.